Welcome to Khetz Tutorials, and in this video I'll be talking about repetition. Now remember, in the previous video we did talk about factorial notation, but we were basically dealing with different digits 0 through 9 or different set of letters of the alphabet, right? So there were no repetitions in the examples or in the discussion that we made. What if we have, for example, let's say you have B O B. Now, the number of different ways that you can arrange this is not the same as if you had different letters, because if you decide to start with one B and end with the other B, let's call this B1 and this will be B2. If you decide to have your set up in this way, then that is one way of arranging the letters. Now, what if you decide to start with this other B? What if you decide to start with B2? Well, you haven't made any changes or you haven't done much, because the arrangement will lead to the same output, right? Now that you have the same output, then that means that you haven't really, this is not really a new arrangement. And what we're doing when we use factorial notation is that we're basically interested in finding different arrangements. So there's a special way that you use to deal with these types of repetitions. So whenever you have repetitions in a word, then you basically have to deal with it in a different way. And that is what I want to talk about in this video. Now, the general form or the general formula to deal with repeated characters or letters is as follows. So you're going to have the total number of options, so total number of options, and that includes your repeated characters. Then you're going to find the factorial of that. Then you're going to divide by the product of the factorial of whatever is repeated. So for example, in BOB, we only have 2 repeated letters and they're B, so that's what you're going to have, and everything else you just follow it. So I'm just showing you this because you can find that a certain word actually has more than one kind of repetition, or it actually has more than just 2 of these repeating. So in this example, you'd say that the total number of different arrangements that you can make from this is 3 factorial divided by 2 factorial. With the top is the total number of letters, and at the bottom you have the factorial of the number of repetitions of a certain type of letter. So if you had a different letter which repeated, let's say it was BOBO, now you basically multiply that as well. So you multiply everything that repeats down here, right? So that is the general form of how you do this. And just as a reminder, when you compute the probability of something happening, then you basically count the number of times that it happens divided by the total of the sample space, or the total of the different arrangements. So for example, a common question in this part of the syllabus basically asks, what is the probability, for example, let's talk about BOB. What is the probability that the arrangement starts with B, right? So we've established that the different number of arrangements is 3 factorial divided by 2 factorial, and that is the total of the different number of arrangements, right? So that is your total, which should go at the bottom, which is 3. And now if you start with B, then you basically have, let's say you start with B, you basically have 2 options left over there, right? Which means you're only dealing with 2 factorial when you do that computation. And that is what you basically have up there, because once you fix one letter, then you basically have one less to choose from, and you have O and B, and O and B are different, so you can basically treat them as you did previously. And this would be the result of that, basically be 2 divided by 3. And you can also just look at your word and actually compute this right away, because you can see that you basically have 2 repeated values. You can just say the repeated values divided by the total. So if the letter that you're being asked for is basically repeated, just count the number of times it's repeated and then divide by the total. And the total being the number of letters that you actually have. So that is a shortcut that you can use to actually find the answer. So I do have an example, but before I go to the example, I just want to mention that if you have a factorial multiplied by b factorial, it's not the same, or it's not equal to a multiplied by b factorial. So 3 factorial multiplied by 2 factorial is not equal to 3 multiplied by 2 factorial. So these two things are not equal, and that is something worth noting. So now let's come to this example. And the example says, given the word probability, determine the number of different ways that the letters can be arranged. So let's first of all check if we have any repetitions. So there's only one P, okay, so there's no repetition over there. And then there's only one R, no repetition over there, only one O. But if you notice, we have 2 B's, and we have one A, we have 2 I's, and everything else is basically occurs once. So there are 2 B's and 2 I's. So if we want to find the total number of different arrangements, we have to find the factorial using that formula that I talked about somewhere here, over here. So the total number of options, find the factorial of that, then divide by the product of the repetitions, right? So if we do that, we're basically going to have, let's count the number of letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. So the answer to A basically be 11 factorial, and now divide by the product of repeated terms. So we have 2 B's. Now that we have 2 B's, we're going to find 2 factorial of that. Multiply by, we also have 2 I's. So that is what will happen over there, and that is what we do to find the answer to that. And the answer in this case is basically 9979200. And this is the answer. That is the total number of different arrangements that we can make, even considering that we have repetitions, right? So that would be the answer. Moving on to the next question, which is B. It says, if the word has to start with a B, how many different ways can the word be arranged? So now we're being told something, some extra information, which will actually restrict the number of options that we have. Now, if we take the B, then we have one less B, and we now have only one B, but still we do have 2 I's. So this is something that we have to notice. So now we're basically saying the first position is taken, and we only have one less of the total number of options. So we only have 10 options now, since we're told that the word has to start with B, right? So it just has to start with B. That is something that we're told. We can't change that. So we can just view this as one of the B's has been taken, so the B does not repeat anymore. And the I is the only letter that actually repeats. So once again, the total number of options, find the factorial of that, and divide by the repetitions, or the factorial of the number of repetitions of a certain type of letter, and that will give you the answer in this case. So once you fix a certain letter, and you can fix more than one letter, you basically deduct from the options, because B is out of the 11 options, so it's taken out, and we now have 10 options to deal with. And the answer to this is 1814400. All right, so that is the answer to that if we are required to start with B. Now, the final question says, what is the probability that the word starts with B? And remember what I said about probability. We count the number of times that a certain thing happens, then we basically divide by the total. So I just write that again down here. So we're going to count the number of times that we can have something, then divide by the total. Now the question is, let's read the question again, basically, so that we can understand what we're basically saying by this. What is the probability that the word starts with B? If you go back to the previous question, it asks for the number of different arrangements if we start with B. So we know the number of different arrangements that are possible if we start with B. And we also know the total of different arrangements, including those that don't start with B. And the total was from the very first question. So the total number of arrangements includes even those that don't start with B, but now we're specifically looking for the probability that a word starts with B, probability that a word starts with B. And we have the number of times, or we have the number of possible arrangements that can start with B, and that is from the previous question, and we can divide that by the total number of arrangements, including even those that don't start with B. And that is how you compute probability. You basically have the number of times that something occurs, then divided by the total of everything. And this will result in the following, right? And that would be the result that you have over there. And once again, I did say that you can actually do some sort of shortcut with this. And since our term is probability, you'll see that we basically have two B's. The total number of options is 11. So you can always use this as a shortcut, but just to double check that this shortcut basically works, you can just do it as it is and see if you get the same thing. So that is all that I wanted to talk about in this video. And I hope it was of value. I hope you did learn something about repetition and how to actually deal with it. So I will see you in the next video.